Hello everyone, welcome back to the channel. In this video we are talking about the interpreter and the compiler. So we need to get our source code converted into machine code somehow before it can run, and there are two main ways of doing this: what's called compiling, and source code what's called interpreting the source code. Both the compiler and the interpreter both have similar work to perform. Interpreter and compiler convert the source code into machine code, which is understandable by computer. In general, computer program exist in high-level language that a human being can easily understand, but computers cannot understand as the same high-level language. So for computer, we have to convert them into machine code and make them readable for computer. In this video, we are going to see the differences between them. Let's have a simple scenario. Let's say it's just you and me. You have your computer and I have my computer, and you are going to write the program that you want me to run now, a compiled language. What happen is you write your source code, and then you have a program called compiler that will go through the source code and create a separate file that contain a machine code, and you just give me that file. This end result is sometimes referred to as executable or executive file. Because I directly execute it, I can now just run your program. You keep your source code and I never see it now. Now with an interpreted language, on the other hand, you don't compile your source code beforehand. You just give me a copy of it, so I will need my machine to interpret it. Whenever I run to your program, now interpreter is different to a compiler. Now interpreter is different to a compiler. It does this on the fly. We can think of it as going through your source code line by line and processing it on the spot. It does not save it as a separate machine code file. Now you have used interpreted language. While they both have their good and bad benefits of compiled code, once it's compiled, it's immediately ready to run, and you could send it to your hundreds or thousands different people. It's ready to go, and it can be optimized for a CPU, so it can actually be faster. You don't need to send your source code to everybody, which might be a good thing. However, the downside are, if I compile it on a PC, the executable file won't work on Mac. In fact, it often need to be compiled separately for different kind of CPU, even on the same platform. And when you are writing code, to compile is an extra step that you have to take every time you want to test your program. The big benefit are I don't really care what kind of machine is on the other end, because we don't provide machine code. We just send the source code and we let the other side to take care of it, and it can be more portable and more flexible across platforms. It's also a little easier when testing, because you just write your source code and then run it, letting the interpreter take care of converting it. There is no in between compilation step. It can be easier to debug when things go wrong, because you are always have access to all the source code. However, it has downside too, because everyone who need to run that have to an interpreter for the language on their machine. It also can be slower because you have to interpret it every time program is run, and source code is effectively public because you are sending it to everyone who need to run that program. Now there are good thing about a compiled language and good thing about interpreted language. There is so many third way of doing this, which is bit of both. Instead of compile model where all work is done up front, that can be a little inflexible, or the interpreted model where all the work is done on the receiving end but can be a little slower. We can do of half and upfront compile it part of way called intermediate language, which takes far long way to machine code as it can get while still being portable. Access first step to take it on their computer is sometimes referred as just in time or JIT compilation. Now this intermediate language sometimes also goes by name of bytecode. So this process has to happen somehow. It's just how much of it happen on your machine and how a few it happen on mine. Now, while theoretically all computer language could use any of these methods, the normal usage of one language tends to be one.